We've learned some rules for dealing with terms that have exponents, and what we're going to learn now is how we can take something that has a radical and turn it into an exponent. What I mean by that is if you've got something that is written in radical form, so something like the square root of 9, just as an example, this can be rewritten so that instead of a square root, it has an exponent. Square roots as an exponent are 1/2 powers. So the square root of 9 and 9 to the 1/2 power are exactly the same thing. So if you see 9 to the 1/2, that's the same thing as the square root of 9, which means the answer, of course, is just 3. If you see it the other way, of course, something like, let's say, 16 to the 1/2 power, 16 to the 1/2 power is the same thing as the square root of 16. So 1/2 power and square root are the exact same thing. So let's talk about what would happen if we had something like this, 5x to the 1/2 power. So in this case, the whole thing, the whole 5x, is not raised to the 1/2 power. Only the x is. 5 doesn't get the 1/2 power. So this would be just 5 by itself, and then the x would be inside the square root, like that. If I wanted the entire 5x to be to the 1/2 power, I would do something like this, 5x to the 1/2 power. This would be square root of 5x. So if I had something like, let's say, the square root of 11r, like that, all of 11r is inside the root. So rewriting this as something with an exponent would be 11r to the 1/2 power. I would need the parentheses there to show that the 11 and the r both get raised to the 1/2 power. So this is a quick way to switch between square root and an exponent. And one of the reasons we might want to do this is because now that we know all of these rules for combining terms that have exponents, we can then apply some of these rules to things with square roots. If we turn the square root into something with an exponent, we could combine these square roots using the exponent rules, which is something we're going to be doing in the very near future.